Hello, and welcome to this introductory video about the Coulomb force. So in this video, we're going to introduce this idea of a Coulomb force. We're going to look at its equation, both in terms of magnitudes and as vectors, and set up a problem that you can try on your own to see if you are able to calculate things correctly using this equation. So the question that we want to sort of set up and have in mind is, maybe we're trying to answer, why does the electron orbit around the proton? As we said in earlier videos, that's what happens in an atom, but why is that the case? Well, as an astute physicist, you already know that it's because there must be some centripetal force. So there must be a force, or a net force at least, directed towards the center of that orbital motion of the electron. So we're basically asking, what is the cause of that centripetal force? What kind of actual real force is exerting that? So let's think. We know one good force that we've worked with quite a lot is a gravitational force. It's a nice long-range interaction between the proton and the electron. Perhaps that's what's going on. So you may or may not know, but this is an expression for the correct description of a gravitational interaction, or the gravitational force, between two objects, one with mass capital M and one with mass lowercase m. And all it is some constant capital G times the product of the masses divided by r squared, and r is just the separation between those two masses. Okay, so you might think that it's gravity, or, guessing by the title of this video, you might think maybe it's a Coulomb force. So, okay, what is the Coulomb force? Well, it is actually a force, kind of like gravity, but slightly different. So gravity is a force that exists just because an object has mass and it's interacting with another object that has mass. The Coulomb force is a force that arises when you have two charged objects interacting. And in this case, right, we have two different types of charges. So we know for gravity that anytime you have masses, they're going to attract. But how are we going to be able to say something about charges? Turns out that the opposite charges attract. So a proton with its positive charge will attract an electron with its negative charge, which is great because we needed an attractive force to try to keep this electron orbiting around. So just like we wanted gravity, we need our Coulomb force to also be attractive, and in this case it is, because opposite charges attract. Having said that, it's no surprise, like charges will repel. So if I try to take another proton and stick it next to the first proton, they'll want to move apart. That's all we're saying there. Okay, in terms of the magnitude of the force, though, the shape of the expression looks a lot like that for gravity. So it's again some constant, only this time the constant is k, times those two charges divided by their separation squared. Now, of course, we've had to introduce some absolute value signs because, again, we're talking about the magnitude, and this time the charges can be negative. And we don't want that expressed in our magnitude. We just want the numerical value without any signs. So we've got some absolute values. Now those constants take on some particular values. These are useful to know, but they'll likely be on your formula sheets. So you could easily start going and computing these sorts of forces. But of course, forces are supposed to be vectors. So let's actually correct our expressions first before we go and try to use them in anything. So here they are in vector format. What we have changed with gravity is we've introduced this little vector here, this r hat. So r hat is a vector which describes the direction of our radial vector. So the hat means that it's only the direction. And what do I mean by this radial vector? Well, it's a vector drawn from the center of the circle, whatever we're orbiting in, out to where we are in the orbit right at this moment. Okay, so r goes, or r hat, points in the direction from the center to where we are, and r as a vector would be pointing in that direction and actually reaching us. Its length would be exactly how far we are from the center. So r, little r there, in the denominator, is just the magnitude of that vector, and then we're squaring it again, so that's the separation squared. That's how that still is working. But the other thing we added was this minus sign. And the minus sign is just telling us that it's an attractive force. So that r hat, remember, is pointing from the center outward to where we are. But the force, of course, must point inward towards the center. So that's why there's an overall minus sign. On the other hand, when you look at the expression for the Coulomb force, again, we've introduced this r hat vector, but you notice we haven't put a minus sign. So why haven't we put a minus sign? Well, let's think about this. Opposite charges are supposed to attract. So when Q1 is positive and Q2 is, say, negative, then we should get an attractive force. If we plug in just the signs, then we notice that we'll have an overall negative sign in our expression down there. And that's perfect, right? Because a negative r hat, just like for gravity, that's pointing towards the center of the circle. And also easy to verify, if I stick in two positive charges, well, those are going to push outward and therefore be repelling like we said they should. All right, so there is our form of the Coulomb force law and of the universal gravitation law. We could now imagine going off and doing some problems. But before we jump right into doing that sort of thing and doing some calculations to answer our question about why an electron orbits a proton, let's first think, just for a moment, suppose that actually the Coulomb force law was the same as our gravitational law. That is to say that it did in fact have a minus sign out in front in its vector form. What would that mean for the interaction of charged particles? So that's for you to think about. And then once you've thought about that a bit, definitely we should go ahead and answer this question. Why does a proton orbit around, or why does an electron orbit around a proton? And you can answer that question by basically looking up some values for the mass of a proton and an electron and putting them into the formulas. Also, look up a typical distance for the electron from the proton. It's basically the size of an atom. And if you look those values up and put them in, go ahead and compare the gravitational force to the Coulomb force. Not to give anything away, but you will find that the Coulomb force is actually much larger than the force of gravity between those particles, hence why we need to consider it in this case.